Welcome back. Let's discuss double angle formulae and also find out how we can prove them. Right? Double angle formulae are as follows. We have sine 2a is equal to 2 sine a times cos a. And then these three are for cos 2a. So cos 2a is equal to cos squared a minus sine squared a. Then cos 2a is equal to 2 cos squared a minus 1. Or cos 2a is equal to 1 minus 2 sine squared a. So what can we use to prove the double angle formulae? We can use the compound angles. Check that. Sine 2a is just the same as sine a plus a. Okay, just same as sine a plus a, like this. So we can use compound angles to prove that this is equal to 2 sine a cos a. And even cos 2a is just same as cos a plus a. And then we can prove these three. Let's do the first proof. We are required to prove that sine 2a is equal to 2 sine a cos a. So we say that sine 2a is just the same as sine a plus a, right? And then from compound angle formulae, we know that sine a plus a is sine a times cos a, then plus cos a times sine a, right? And then sine a times cos a is just same as cos a times sine a. So sine 2a is equal to 2 times sine a cos a. Done. That's the first one. Let's go to the proof number 2. We are required to prove that cos 2a is equal to cos squared a minus sine squared a. We say that cos 2a is just the same as cos a plus a, right? So we're saying cos 2a is equal to, using this, is going to be cos a times cos a, and then minus, remember the compound angle formula, minus sine a times sine a. Okay, so meaning that cos 2a is equal to cos squared a minus sine squared a. Okay, that's the second one. Let's prove the third one. We are required to prove that cos 2a is equal to 2 cos squared a minus 1. Right, we say that cos 2a is equal to cos a plus a, like this. So meaning that cos, we've done this one in the previous one. Let me just write that. We just proved that cos 2a is equal to cos squared a minus sine squared a. Remember this. Remember that sine squared a plus cos squared a is equal to 1 from grade 11. And then from this we can see that sine squared a is equal to 1 minus cos squared a. And then also cos squared a is equal to 1 minus sine squared a. Okay, these two are coming from this one. So now, where there is sine squared a, we can put 1 minus cos squared a. So it becomes cos 2a is equal to cos squared a minus, and then put in the bracket, 1 minus cos squared a, right? And then remove the bracket. Cos 2a is equal to cos squared a, then dispute negative 1 there. It's going to be negative 1 plus cos squared a. Then cos squared a plus cos squared a is 2 cos squared a. So cos 2a is equal to 2 cos squared a minus 1. Okay, let's go to the fourth one, the last one. We're proving that cos 2a is equal to 1 minus 2 sine squared a. So we say that cos 2a is equal to cos a plus a. And then we just prove that cos 2a is equal to cos squared a minus sine squared a. And then we agree that cos squared A is 1 minus sine squared A. Okay, then so it's cos 2A is equal to 1 minus sine squared A, right? And then minus sine squared A. So if you remove the brackets here, we'll remain with 1 minus sine squared A minus sine squared A. It becomes cos 2A is equal to 1 minus 2 sine squared A. We have proved all the four.